A vector field is a function whose input is a point, and that could be an xy ordered pair in R2, or it could be an xyz ordered triple in R3. This point is input into the vector field function, and then it will have an output that is a vector. The output vector is usually graphed so that the initial point of that output is located at the domain element that generated the vector. In other words, the output vector is coming out of the ordered pair that was used to generate it. Let's take a look at an example. Here we have a function that represents a vector field. Notice that these input values are points in space. That could be a 2D point or a three-dimensional point. Let's graph this vector field by first starting with a table of values, and let's begin with the ordered pair 1, 0. So the horizontal component of our output vector is going to be the opposite of the y-coordinate, which is the opposite of 0 or just 0. The vertical component of our output vector is going to be the x-coordinate, which is 1. Now we're going to graph this output vector starting from the ordered pair 1, 0, which was the point used to generate the vector. Now with an initial point at 1, 0, we're going to move 0 in the direction of x and 1 in the direction of y. Essentially, we're going to move straight up to get our first output vector. Now let's look at another ordered pair domain element. Let's look at 0, 1. When 0, 1 is our input point, the output vector is going to have a horizontal component that is the opposite of the y-coordinate, so that's going to be -1. We'll also have a vertical component that's exactly the x-coordinate, which is 0. And so we have the output vector -1, 0 that's going to be graphed with an initial point at 0, 1, which was our domain element. So now we'll move -1 in the direction of x and 0 in the direction of y to get our output vector. Let's look at the domain element -1, 0, which gives me an output vector where the horizontal component is the opposite of the y-coordinate, and again, that's 0. And the vertical component is exactly the x-coordinate, so that's -1. We graph this output vector having an initial point at the ordered pair, -1, 0. We're going to go 0 in the direction of x, -1 in the direction of y, and that is this unit vector down here. So let's keep going with this. Now let's look at the ordered pair 0, -1. We'll get an output that is a vector with a horizontal component that's the opposite of the y-coordinate. The opposite of y is going to be just +1, and the vertical component is going to be exactly our x-coordinate, which in this case is again 0. So now we're going to graph this output vector having 0, -1 is the initial point. So we're going to move 1 in the direction of x and 0 in the direction of y to get our fourth output vector. Let's look at 4 more ordered pairs plugged into this vector field. 2, 0 is going to generate the output vector 0, 2. 0, 2 generates the output vector -2, 0. -2, 0 generates the output vector 0, -2. And 0, -2 generates the output vector 2, 0. So at 2, 0, we're going to go 0 in the direction of x, 2 in the direction of y. At 0, 2, we're going to go -2 in the direction of x and 0 in the direction of y. At -2, 0, we'll go 0 in the direction of x, -2 in the direction of y. And at 0, -2, we'll go 2 in the direction of x and 0 in the direction of y. Now this is a vector field that could be considered a velocity vector field that represents the motion of a wheel. If we think about a point on the inner rim of a wheel, this velocity vector could represent the direction of motion, but also the length of this vector or the magnitude of this vector would represent the speed of that object at this particular point. When the object is located in this position, it's traveling in this direction, again with that same magnitude or that same speed. However, if we have a point located out on the outer rim of a wheel, notice that it's moving in the same direction, but this time the magnitude, we'll call this magnitude of the outer point, is much larger than the magnitude of that inner point. Remembering that the magnitude of the velocity vector function is equal to speed, so this vector field could be one that represents the motion of a wheel.